Our first speaker is Robin Deterring, and she is an expert in the care of children with rare lung diseases, and she is really developing very innovative strategies to improve outcome. Robin.
Can you hear me? I'm a walker, so I'm going to move around. Well, welcome back. I hope I'm also a little bit of a teacher, so if I see anybody sleeping in the audience, you'll be lasered and asked a question. Okay, so none of that right after lunch, and no dimming the lights either. But thank you for inviting me, Larry. I'm actually work at Children's Hospital in Colorado, and I live in Boulder, so I have the best of both worlds, but I don't have the best of both worlds in between those two places. If you live close, you know what I mean. But I get to speak to you today about something that I'm very passionate about, and I think you'll understand some of that as I go. So there are many brilliant people in this room, and it's always a little intimidating to think about speaking about things. But when I thought about this talk and the diversity in the room of background, I thought perhaps it would just be best to give people a perspective, no matter what your background is, of a journey that I've been on for most of my career, and give you a perspective for how a physician might be touched by a thing that changes their life. And as part of this journey, hopefully there'll be something in this room that everybody can connect to, be it some leadership activities about how you develop things, really cool science, pediatric lung disease, something for everyone, I hope. So I'm going to talk about a journey and make it a little personal to my experience, a broad journey, looking at how you create a global collaborative team to take on a problem, a zebra roadmap, and by the end of this, I hope you all want to be zebras. Talk about then some of these different components to this roadmap. So I'm going to give you a little background so you know where my passion comes from. So this background is on the children that I take care of at Children's in different places, and we call this CHILD, or Children's Interstitial and Diffuse Lung Disease. This isn't one specific diagnosis. It's actually a term we use to call many different diseases that are rare with very significant problems, morbidities, and some of these children don't survive. Actually, just heard about one of those conditions in the last talk that he talked about. Many of these individuals have a rare problem, but collectively, actually the group of children that we take care of, there are many children around the world that are afflicted. They're seen by many different people in the physician world and in different places, but they're usually underdiagnosed. And they end up and finding their way ultimately to pediatric lung specialists experienced in this area. If you can't get off oxygen, you're going to end up with the pediatric pulmonologist. So what are these type of conditions that we're talking about? There are many, but I wanted to give you a flavor for these. So some of the conditions that we take care of involve mutations in a gene of surfactant. And surfactant is really the lubricant of our lung that lines the lining space of the lung, and it's critical to keep our lung inflated so it doesn't deflate with each breath. You need to have the lungs stay open so it's not hard to breathe each time. So it's critical for survival. Premature infants have it underdeveloped, and we can stimulate it because the genes are normal. But if individuals have mutations in these protein genes, they can have very severe lung disease, and this has been part of the group that we've been very involved in studying. Another group has been involved in something called NKX2, and the name's not important, but what is important is that this protein that is made by this gene is the master regulator of the lung. And so we didn't know this. We just found these kids. These kids come in, they have these problems, and we started trying to understand what happened. And as it turned out, they had this mutation. So this is the first gene that turns on to make the lung a lung. And so it becomes very important because not only is it important in the lungs, this is green fluorescent protein that stains this protein in the lung, the thyroid, and the forebrain. So these children have a condition called brain thyroid lung syndrome, and it's a dominant condition. And then we take care of kids who have airway disease. This is a normal lung. It's, I think, the most important organ in the body, so hopefully you will be thinking that when you in. It's a very delicate organ. The gas comes in here and exchanged with blood vessels here so the oxygen can go into the bloodstream, the carbon dioxide can go out. It's also exposed to the outside world, so it's really an immune-mediated organ. So it has a lot of function, and when it goes wrong, you don't do very well. And these are some of the conditions we treat. Problems with air tubes here. These are lung biopsy samples in the lung. Immune-mediated problems can attack the lung, and autoimmune disease can attack the lung, and these are in children. So a big umbrella of different conditions. So rare disease, a moment, I know you're going to talk about this tomorrow, but rare disease is really defined as something that affects 200,000 people in the United States. About 7,000 rare diseases exist, and many of them are in children. So 25 million Americans have rare disease, and 80% of those will present in childhood. And as a pediatric pulmonologist, the majority of what we take care of, unless you have asthma, which just happens to be the most common chronic illness of childhood, or probably premature lung disease, most other things we treat, including cystic fibrosis, for those of you who know that, are rare. Unfortunately, this is really tough for people because there's no usually treatments or they're ineffective and haven't been studied. They're frequently very complex to think about. They're underdiagnosed. They usually need a specialist to see, and many of them are caused by genes or constellations of genes. So that's kind of a little bit of a background. Now I'm going to step back in time to when I was early in my training. I haven't changed much, but I'm going to take you back. So back in that time, child, or the conditions I treat, it was a very confusing time for everyone. So I would say this is pre-2004. No, I trained earlier than that, but we'll talk 2004. And at that time, the terminology was confusing. We didn't know how to call even those mutations that I talked about. Children would just walk in. They needed oxygen. They breathed fast, and they were very sick. People would go to the literature, and they'd say, oh, that child has what this adult had. So we treated child like adults. The diseases were poorly defined, and it was very difficult to even study it because we didn't even know how to call it or classify it or teach anything. And imagine if you had a child and you came in, and I'm going to show you some of those children in a second, and you had a child who had a life-threatening disease, certainly a disease that was going to last a long time, and we didn't know anything more than this. So it looked a little bit like this. What's wrong? What will happen? And early in my career, I did a lot of, I don't know. Then it would say, well, how long will it last? And will he need oxygen for a long time? Can he go to school with his oxygen? So what's the treatment going to be? I don't know, to all those questions. And this was always the hard one, will he survive? Sometimes I knew that. So these questions, as a young junior faculty member, became much more difficult to answer. I enjoyed what I did. I was in a lab studying adult ILD, or lung disease. It was going well, but these patients were really starting to weigh on me because they seemed to come see me. I enjoyed thinking about their problems, helping these patients, but it really was feeling frustrated because none of us knew the answer. And then I had an experience, and this is for people who are junior in their career and what I talk to people about. Those moments come in your life where all of a sudden something changed. And I had one of those moments with one of these kids. So we had a child with one of those mutations in a surfactant. We knew enough to know that's what it was. We didn't really know much more. The child was about 3 months old, got a pneumonia, came into the hospital like a typical pneumonia, and we started treating it. It became very clear that that wasn't the problem, that they had one of these conditions. We spent the next 8 months doing everything imaginable we could think of to treat that child. And in the end, it became clear that the only way forward was for a lung transplant for that child. And that family, as some families do, decided that wasn't a choice for them, that that was something that they wouldn't choose for their child. So we knew what to call it. It was one of those surfactant mutations, but we didn't know much else. And that family was incredible. They were there every day. It was one of those things as a physician, it was very hard to continue to see a patient that you know you don't have much more to do for. Maybe you've been there as a family, maybe you've been there as a physician. And then when that day came that the child didn't survive, the family said, "Thank you for all you did." And I really had to go home and think a lot about that. I'd been thinking about this, and I said, you know what? I didn't do anything. In fact, I didn't do enough. And those moments come in your life when you have one of those moments, and then you say, you know what? I don't know isn't good enough anymore. I didn't know what I was going to do, but that just was a change for me. I'm just not going to do that anymore. There's got to be more to do for these children. And that changed my path, and that changed my career, and this has been a focus of mine since that time. But at that time, I was just a junior little young pup, and I decided I was going to do this, and I knew something. I needed a team. I needed to find a team to do this. How was I going to do this? The NIH had sponsored a rare lung disease consortium where some of my colleagues in the lab were a part of. And I asked, can we do pediatrics? Can we join? Can you help us? And they said, sure, come on in. So they said, what you need to do is you need to get families together. Dr. Swanson's comment about the family, the patient is at the center of this is absolutely true. Get families together and get them to help you. In 2004, we formed the Child Foundation. 6 brave families came together to talk about how they were going to help other families, including one family who had lost a child with the mutation like the child I had just lost as a physician. And then I brought other physicians together, and as it turned out, they were having the same frustrating experience I was with these kids. The same helpless feeling, looking across at families saying, I don't know. So we came together about $30,000 to have a meeting to start this. And since that time, the Family Foundation has been doing support and education. The physicians have been defining, clarifying these diseases to study more. And I'm going to fast forward you to now, because I'm going to start now from back to forward about where we're going. And what's been exciting about this journey is that we now have a research network that is at most of the major children's hospitals throughout the US, and, I don't know if it's there, around the world. So we have research centers now studying these diseases. The Child Foundation, we founded that, also has affiliates around the world. And what I learned, the other thing I learned is this doesn't have to take a lot of money. I wanted more money. But it didn't have to take a lot of money because this was passion that drove this. This took money to have meetings, to get people together. Took some fundraising to have some initial grants. But it was about really bringing people to the cause that developed this. Because we don't have a major NIH grant, nor did we. But what we had were passion about having children who were sick that we didn't understand. So we've had some success in this, and so the systems, you have to have systems to approach a problem. And they're big systems. They're physician systems, they're scientists, they're families, they're collaborators, they're people who do internet now groups to raise money, and innovations and thinking about rare disease as we begin to develop this problem to move further along. So we've had some successes. We've had national meetings together for 10 years. So what was unique about how we approached the problem is that the patients were at the center of what the physicians saw. That's why they were there. So the patients were always at our meetings. And the patients looked at the physicians as vehicles for which there was hope for their children. So our meetings were so important for each group because they gave each group hope and energy to move forward. We had an Oxy Kids Camp because these kids are on oxygen a long time, and they don't usually know anybody else on oxygen, so the Oxy Kids Camp is there. We produce educational materials for the families to go hand their physicians who didn't understand the problem. We've had multiple publications now as a research network to begin to define the field and study it. We've had grants, and we've brought tremendous scientists to the field to study our diseases because, as it turns out, some of the diseases that I talk about are very important in other diseases and lung development. As I mentioned, our diseases in our organizations are worldwide, and this is when you really know that you've arrived, and maybe some of you will understand. I hear some giggling. So U.S. News and World Report, that's very important to hospitals, and when U.S. News and World Report wants to know if you're a part of our research network to get a credit in pediatric pulmonary, that's when you know that you've arrived. So we've been very successful in our 10 years, but you know, it's still, I say this is good, it's been fun, but I come back to that, but I still don't know a lot. I still don't know what I need to know, and I still am saying that way too much. So as part of the Child Foundation board, we underwent strategic planning. And this story, by the way, if you're part of other foundations, is generalizable to many things if you're taking care of other diseases. It's the process people go through, but it's the journey that I'm sharing with you. And our goals became to talk about cures, not treatment, cures for disease through research and discovery, education, because these families, these children are unique, they don't have the information they need. And many times in rare disease, family and children, the families know more than their local physicians, so they have to be educated. And support for each other, whether it be through internet, through our gatherings, and many of these families find very close associations. So now I'm going to take a look at the future about how we've decided to organize moving forward. So, you know, I actually was entertained by all that singing. Are they here? So I thought it was very good, and I think I run into physicians who are really down on medicine, and I think it's the most incredible, exciting time to be here and be a part of this because of what's here. And I tell my kids, I want you to be physicians and in medicine, which assures they won't be, probably. And where's Dr. Swanson? You didn't talk about emoticons. That's all my 13-year-old wants to do, by the way. But anyway. This time in medicine is very important because we have 3 huge tectonic plates changing. IT advances are incredible in what we can do with data. You're hearing about that. Molecular technology that I'll talk about, and you're also hearing about, and healthcare change. And these dynamics will create tremendous power for what we do in medicine, and medicine is already changing. But in 5 years, the kids I take care of will be dramatically changed by this. And it'll be related to precision medicine. So our roadmap forward includes the medical record, big data, smart forms, so we can harness electronic data that are going in clinic, molecular data related to genes and proteins and stem cells, and then healthcare change and how we can use healthcare change or adapt to healthcare change to move things forward. So zebras. So has anybody seen this? So on rare lung disease, I see everything's lung. On Rare Disease Day, Siren put this out. And I loved it. I told my administrator, go print this out and put this on my door. And it sits on my door because I really believe this. So if you're teaching medical students, it's still a common saying, if you hear hoofbeats, think horses, don't think zebras. Because medical students are the best at thinking of the rarest thing when the common cold is sitting right in front of them. Okay, so that used to be the saying, but it's changing because what this means is as we get further along in this revolution, we all are going to be zebras. We all deserve to be treated not in an average way, but a much more precise way. And that's what rare disease is. Rare disease is you have to think very much about that small group. But as we move further and further in healthcare, we all will become much more well-defined into smaller precision groups. So we all will be zebras. That's the roadmap of rare disease. And that's the roadmap for common, too. So I mentioned part of what we're embarking on and actually doing is now in the clinic when you come in and we take a medical history, we're coming up with smart forms, working with our electronic medical record company with defined data elements so that when we put our data in the electronic medical record, it is the right data we need to study this disease, to know what we need, and it downloads to a database in the back end. So I don't have to pay researchers to go through loads and loads of record. And what's even better is Epic, our medical record group, will download our smart form from the cloud, sounds like magic, download it from the cloud so that it harmonizes data across the country. We get the right data on these rare disease patients. Very important. This seems simple because I know people in the room are very advanced, but I just want to walk through it for people who may not be in medicine. So the omics, people will talk about omics. And just to be clear, you've heard a lot about DNA. These come from genes, and in my opinion, tell us what can happen. You've heard about RNA. It's the translator of DNA, and it talks about what may be happening between the DNA and the protein, which is really what your body's made of. Real time, right here, now. It's what drugs interface with. And this area gives you proteomics, this is genomics, and this is transcriptomic. And this is really what defines us. These are the waste products after things are processed. So this is the omics world. And in our rare disease field, we're focused on genomics and proteomics. So this is how genomics might work and how it's worked in our group. So we have a family that came to see us, and they have a disease. They have 3 members in their family, all girls, at these ages, who have a lung disease that will not be survivable. It is chewing up their lungs. It looks terrible. And when this daughter was 6, and this daughter was 2, and this daughter was 1, you could see it coming in all of them. And the family was frantic. Well, it just so happens that we now can sequence the whole genome. So everybody said, well, they've got a gene problem. And that's what we used to say, but nowadays we can say, you got a gene problem, and guess what? Let's go find out what it is. And so with this family, what we were able to do is we were able to sequence their whole gene, and because there were so many family members affected, and not the parents, by the way, they just had 1 gene and not 2, and unfortunately the bad luck is all these kids inherited the wrong gene from each parent, that we were able to define a new gene. And now with that new gene, we've been able to look around the world, and now we have a gene for other families with this disease. So you have to understand things to be able to fix it. That's how the genomics are pushing the envelope in some of these rare diseases with these genes. And this gene, by the way, is on a macrophage, which is a very important cell in the lung, and will be involved in other more common diseases. This is the work that we're doing here with SomaLogic that I'm very excited about. It's looking at protein profiles. So in 1 drop of fluid, I like to, and I have to sometimes look in children's lungs and take fluid out to diagnose their problem. If I have 1 drop of that fluid, now using this advanced technology from SomaLogic, we can look at 1,200 proteins and soon more. And with that, we can look at diagnosis, prevention, and potentially prediction of their disease. Now, diagnosis is really important because remember I showed you all those lung biopsies? That's because they all get biopsied. If I have a kit that can diagnose them with proteins, that's very important in rare disease. So we're thinking about proteomics in this way. So big data. This is broad overuse, but this is how I see big data for my patient, with the patient at the center of this. Their proteins, and there will be many defined. Their genes, their electronic medical record. What are they exposed to? What do I see? I didn't talk about it, but the microbiome. What bacteria are part of them? And then this big complex thing here is all the pathways that are involved. This is incredible complexity. But IT and how we understand data is growing. Google can analyze terabytes of data in a second to do your searches and to add all the videos. And they're getting into the game. This is going to be powerful for this patient. Looking past the individual patients to the groups, I want to understand these diseases. So now the disease is at the center of it. And now I look at the same things and say, can I understand groupings of this big data set with cognitive computing to understand how to diagnose and treat these different conditions? This is part of our pathway. And then I want to just end on this idea of cure. So the foundation group said, but we want to cure 1 lung disease. Is it possible? And I believe it is. And I believe it is through something called a stem cell. So our group, we're very fortunate by serendipity to get attached to a brilliant scientist in Boston who was doing the top stem cell work in the lung. And here's how it worked. It worked like this. I was at a meeting, and I had those kids. I had 20 kids with that NKX thing, and this guy is giving a big symposium, thousands of people in the room, maybe not thousands, okay, 800. And so I go up to him afterwards, and people are waiting in line, and I don't know him, and I'm just waiting with my little poster, and I walk up and say, well, Dr. Cotton, that's a great talk, and I have these little kids, this is this gene, you mentioned it, you might be interested in it, might be helpful. And I said, because what could I lose? He could just say, nice. But instead, you know what he did? He did something that changed, again, what I do. He said, you have patients with this? Yes. He said, all of them? I said, yes. He said, I'm taking no more questions. We spent the next 2 hours talking about these kids, and since then we've worked together. And he has stem cells from these kids that I believe will change not only these kids, but others. So part of this story is be courageous and don't be afraid to ask. It may change what you do. So how will it cure these kids? In my remaining time, I want to show you a story of how people are thinking about stem cells. So these are not embryonic stem cells. These are stem cells that come from a patient, from skin. They can do it from blood. And they reprogram them by putting on different chemicals, different mediators, because in lung development or any other development, they know what drives a cell to become embryonic. Okay, so this is this patient's cell or one like them in a dish, put this on it, they become like an embryonic stem cell. Then they put different mediators on it, and they can make a lung, they can make a kidney, they can make a nerve, any cell in the body. So you all could have stem cells today made. Potentially any cell in the body. This will change medicine. But with these kids who have a mutation, one mutation, it means from this kid who has one mutation in those surfactants, they can do this. Here's the other science fiction. They can cut out the mutation, make it right. And now in that cell, they have a cell that's right and a cell that still has a mutation in it. And they can study drugs, and they can study differences in that cell that really understands things. And then the science fiction is, how do you get it back in? That's a ways away, but drug models and drug screening models are not a ways away. They are here today. So this is incredible work. I think it's science fiction. It's so fun to be a part of this, to bring this to these kids. And these are stem cells, again, that Dr. Cotton has, based on that conversation. Don't be afraid, if you're in the audience, to ask the question. So our zebras have informed the common. Mutations in surfactant proteins are believed to be involved in biomarkers for chronic obstructive lung disease. Lung disease of prematurity, the babies, they have mutations, or not even mutations, but abnormalities. They can have an increased risk of lung disease at birth. Adult pulmonary fibrosis, lung development, and thyroid development now from these cells. Zebras are informing the common. Taking it back to the families, we haven't forgotten them. We've developed, through the web, seminars, educational materials. We're having conferences still. This is our Boston conference, and this is one of the best conferences I go to in the year. I look forward to it. It recharges me. And then back to the families. They are the power. They're our only way forward. The NIH is very good at what they do. They study mechanism, and we have to understand that. What I need to do to move this forward, to be true to that patient I lost that many years ago, is I need to do many things, and the NIH can't possibly fund all that. But families care and can. And it's more than those families, because families with COPD and premature lung disease, they're having these problems too. So it's patient power. It's what Dr. Swanson talked about, how you get the families activated, because that's really the business plan forward. That has been the business plan all along. So what I've hoped to show you is that a couple different things about my journey. One, serendipity. Two, it's created such passion in me. Three, look for those moments that happen to you and follow them. Four, if you're going to look at lung disease, rare disease, you have to have a game plan. I've talked about these different areas, but it really is a combination of multiple types of people together to make a difference. So on this journey, where has it led? Well, I think zebra. That's how I think. I do rare disease. I think zebra about asthma, because asthma isn't asthma, it's zebra. I think zebra about what we need to do in medicine today. So hopefully some of you will become zebras with me today. I think systems and big data. I think passion and excitement and courage. I don't hesitate to ask if I think something good can come out of it. I think patient power. And it's been such a fun thing to be the conductor of this thing that I could never have imagined. So I'm glad I got a chance to share that with you today. I hope that there was something in that you could relate to. I've taken these ideas now at Children's Hospital as part of the Breathing Institute, and I've showed this slide now twice. So this has been part of my journey. I do talks around the world. This is in China, Mount Tai. There are 7,200 stairs up here to the top. I also made that journey. So with that, I'll take questions.
Thank you. That was really great, Robin. We can take some questions. Yeah.
That was a really impressive, impassioned talk. And
Good.
I liked how you tied the rare disease work to the scientific work about more common diseases. But I wonder if you could tie the development and engagement work to more common diseases. So one of the things that struck me about the rare disease conferences that I've been at is how the patients and the scientists and the physicians are there together, how that sense of engagement and everybody kind of pulling in the same direction is very powerful in getting results. And I don't see that at diabetes meetings or cancer meetings or things like that. So what lesson do you have for us about trying to get that level of multiple communities engaged together and inspiring each other in more common disease areas?
That's a good question. I think that maybe we don't do it. I mean, there's a lot of attention paid to common issues. I'll speak asthma because that's also what I do and I know. So in pediatric asthma, there's a lot of resources for asthma. There's a lot of support, not this kind of support, community support, but there's a lot of, like in my day, we have a big working group. They have a lot of resources. Community docs do a lot of asthma. So asthma is kind of seen as, it's pretty common. Doesn't everybody have asthma kind of thing? And there's not this urgency around being alone. I think that's some of it. But then I also say, but have we really tried to start? There are groups, mothers with asthma, there are groups, but they don't get invested in quite the same way because part of the driving force in these rare diseases is they feel alone, misdiagnosed, and don't have as much hope as I think some of the more common diseases do when they hear about research and things. But I think we may not develop it, we may not activate it as much as we could. I think we could do more. I don't know if that answered your question, but that's what I see.
Yeah.
One of the things the Cystic Fibrosis Foundation did was to track clinical outcomes and intervention strategies across all the centers in the U.S., which produced a pretty dramatic improvement in care without actual new therapies. I mean, just a sort of strategic strategy. You know, obviously a lot of your patients aren't near you. You don't get to see them very often. I'm curious how good the learning network is among the child lung specialists and how you share, non-genomic, non-drug-based strategies for how to actually solve problems in the patient's lives in an effective way.
That's a big question, very important one. So some of the strategies, first I'll say that cystic fibrosis is a rare disease that, in my opinion, has changed the world in how we see medicine. We're the largest CF center in the country, and I grew up as a CF doctor, and in fact, that's my pedigree and what I was able to do, frankly. But I think that what I talked about with electronic medical record has the power to do some of that. You have to harmonize data sets. CF does that, by the way. They harmonize how they standardize their clinics, how they standardize their data collection. But they're doing it through record reviews. So these smart forms in the electronic medical record, that's the way forward to harmonize data across the country, not locally. That's the big data difference across the country. CF has had the money and the power, the guerrilla power to do that. They've also said, you're a center of excellence, you're not. And the foundation gets to say that. What do patients think is the most important thing they need in care? And they get to say, you are, you aren't, you are. So, and CF has done that. But they've had money to be behind that. But where did that come from? It came through passionate families and physicians. It's the same strategy, only 40 years ahead.
You have another question here?
But haven't the CF folks also shown that you can double survival with imprecision medicine?
Correct.
Yeah, by adopting these sorts of rigorous clinical guidelines that have a lot more to do with infectious disease and respiratory therapy and family engagement than searches than, for example, gene therapy.
That's true. So the gene for CF was discovered in 1989, and people thought, well, that's it. It's going to be cured. But that wasn't the case. So they have been, CF survival 40 years ago was 5 years of age. Median survival now is about 35. And there's been great discoveries that I suspect these patients will live close to full lives now with some of the recent discoveries. But he's absolutely right. They understood enough about the mechanism of disease to intervene in that end, like the end, disease spectrum end, like all the mucus and all the infection. Treat that. They knew enough to do that to improve care and survival. But through this kind of a strategy with omics and genetics and high throughput drug screening on cells, they now have jumped over and they have drugs. Actually, the FDA just approved double combination therapy for the most common mutation in cystic fibrosis that will treat most genes in CF, or most kids who have this gene. And these medications will improve survival at the level of the mutation defect. So these drugs will work at that level. But you're absolutely right. Beforehand, understanding enough about disease, talking about infection control, simple things, organizing, made a difference.
Okay, one more question and that's it. Go ahead.
So just about every major pharmaceutical company has got a rare disease group these days. How do you interact with them and how do they interact with you? And are they a source of happiness or pain?
Can you tell? Yeah, so that's true. The pharmaceutical companies have driven the development of some of these networks because to develop a database, I mean, we've done this, we've done a lot without a lot of funding because it takes passion. But having pharmaceutical company with clinical trials behind them really improves your infrastructure and your ability to drive excitement and new therapies. So we do have actually pharmaceutical companies coming to talk to us. Pulmonary fibrosis is a leading or a common disease in adults that has a poor survival. And there now have been 2 drugs come on the scene, FDA approved for adults with idiopathic pulmonary fibrosis. Those companies now are coming to our network saying we would like to study that in children with pulmonary fibrosis. So when that happens, it allows us to have infrastructure to develop our behind-the-scene registries and our strategies a little bit better. But pharma has been very important in these ways. As long as you stay true to your mission with pharma, I would say that's very important. So I suspect they will be coming to our network and have related to the pulmonary fibrosis medications on the market.
Thank you very much, Robin.